So we are discussing the theory of pointers, how it is working and all, pass by value and pass by address kind of a story. That's what we were discussing. And I guess, yeah, so this is the program that we discussed in the last session, PNK. Of course, this is the program. And we printed the values of this %d. If I say here p is equal to comma p, sorry, p and printf ampersand of k is equal to %d, comma, let's say k, and we will dereference the address. Dereference means we will access the value stored at that particular address. That is asterisk symbol or a star symbol, but it is called as a dereference operator. Star p is equal to, then accessing the value and printf, okay, and then k is equal to %d, comma k. Let me immediately put some new line characters after the output. Now, if we run this program, we have actually executed this program in the last session also, and we know that the values are quite same. The pointer variable is pointing to the same value which is stored by k. In one case, we are accessing it with the address. Now here you can see that the value of p and the value of k is very same, right? And star p is pointing to the 1 and k is also pointing to 1. Now, we have seen one interesting thing that this DRR2, it's getting reflected when we are trying to access, when we pass an array like this, when we are passing the array and when we modify the array value in the method, that value gets reflected into the main method also. Because here, when we pass an array, we have now understood that whenever we use an array variable, that time we are not passing the value, we are passing the address. So that is what we have understood. Okay. So now if I, let's say, to proceed with the pointers, let me also put a comment on this all code. So section wise, I'll be able to uncomment the code and or remove the comment of the code and use it. So I'll keep this code in comment as in a separate entity. Now what we will do is, let's create an array integer ARR of size, let's say 3. Okay. And let's initialize these all locations with the index value, like ARR of 0 is equal to 1, ARR of 1 is equal to 2, and ARR array third location is equal to 3. Now we have 3 values in the array. Now what we are saying is, if I print this array, if I print this ARR variable %d, and if I print ARR, it will print the starting address of the array. ARR is equal to start address of the array. That is what for sure. Let's verify. Now you can see that the ARR holds the starting address of the first location. Now, if that's true, like, what is the pointer variable? Let's create a pointer variable star p. And what we have done is, if I say integer k is equal to 1, and here I can say that p is equal to ampersand of k. That means we are holding the address of k variable in p, right? Pointer variable. And then if we apply asterisk, then it dereference the address and prints the value of that particular variable on the screen. Now, is it true for the ARR variable? Is it true for the ARR variable? Let's verify, because if when we are running this program, we can clearly see that the ARR is printing the address. Now, if we dereference this address, with the uh, asterisk symbol, that's what I'm saying. Like, this is sometimes called as a star or a asterisk, or in the programming world, we call it as a dereferencer. So what is the meaning of dereferencer? Dereferencer means go to the memory location and print the value. So you have a value. Let's say uh, this holds a value of, let's say, 2. So this location holds a value of 2, and this have address 0000. Let me see. This have address 0000, and we also have a pointer variable. Let's say you have a pointer variable called as p, and this pointer variable also have three aspects: its label, its value, and address. Now this pointer variable will be holding value 000, right? So if I access only p, if I print p, it will print 000. But if I dereference this p variable, if I say star p, then what is its meaning? Star p means go to the value of this address. Now, what is the value stored in this address is 2. So if I access star p, it will print 2, because you are dereferencing the address stored in the pointer. So that is the meaning of the star a. Now, what we are doing in the program, we are saying that the ARR, what we are confirming is the ARR is holding the address of the start address of the array. So this first address of ARR 0 is held inside the ARR variable. Because what is the formula to go to the particular index? The formula to go to the particular index in the case of the array is base address plus index multiplied by size of data, right? This is the formula using which we can go to the particular index. Now for the first element, the index is 0. So anything into 0, 0. So obviously base address of the ARR and the address of the 0th element in the array will be same, right? Now if the ARR of 0 and ARR are referring to the same address, and if we apply this asterisk phenomenon, like if I access the ARR like this, if I say ARR is printing the address, for example, it is printing 000 in this case, what will happen if I access star ARR or the asterisk ARR? Will it print the value? That is the question. Will it print the value even if we are creating an array variable, right? So let's verify what will happen. So if I say printf asterisk of ARR, that is a dereferencer of ARR, is equal to %d comma star ARR. Now let's run the program. Okay, what we will do is, one more thing we have to do is printf. I'm forgetting this new line character every time. Printf ARR of 0, okay, is equal to %d, and here we will say ARR of 0. Now if I run this, oh, I have one missing comma. If I run this, okay, have I done any mistake? Yeah. Printf, what it says.
The spelling of printf.
Yeah, okay, thank you. Printf. Now let's see. Yeah, okay. So here you can see that if we apply the asterisk symbol to the array variable, and if we are accessing the first location of the array variable, they are going into the same location. So what is the conclusion of this discussion? Conclusion of this discussion is the array variables are pointer variables. Array variables are pointer variables. What it means is that you are storing the memory inside or the address inside array variable. So whenever you see ARR or the array variable with the brackets, that time immediately start thinking in terms of uh, pointer variables. Sure. Now, if this index is telling the array that you are accessing, suppose you are supposed to access the first value from the array variable, can we apply the formula, this base address index into size of data? Can we really apply this formula with the, let's say, asterisk symbol? Can we really apply this formula and use the asterisk symbol to access the location? Let's verify that. So if I say printf, I want to access star ARR plus 1. This is the location that I am interested in. And if I say %d, and if I say, okay, I want to go to the location ARR plus 0. This is my base address. This is my index value. And I'm not interested in the address. I am interested in the dereferenced value. I am interested in the dereferenced value. So let's see what happens. Let me close this. Let me run the program again. So here you can see that. Sorry, I should use here in the display, I should use 0. Right. So I was accessing 0th element and I printed it as 1. Now you can see that using asterisk symbol also, with the addition of the index, we are still able to access the array. And this story holds true for the rest of the locations also, like ARR plus 1 is equal to %d, and of course ARR plus 1, that is adding one index and dereferencing the value. Of course we have to dereference it, otherwise we will get the address of the second element in the array. Okay, let me put a slash in the earlier statement. Let's run it again. Now here you can see that ARR plus 1 really goes to the second index of the array. So is the part clear that array variables are the pointer variables and you can really access them with the concept of dereferencer? Okay. Anyone have a doubt? Okay. Sure. So, okay. Now let's try to create a particular program. Let's try to play with this concept of their pointers, and let's understand what will be the effect you people we will get if we are dealing with the address instead of the value, right? So now I'll be deleting this part. Let's delete this content, and oh, instead of deleting, I can still make use of comments. So if I need this for the other reference. Okay, now I'll uncomment my method calls. I'll use this thing again. Now what we are doing in the methods, we are in the first method, integer data, get data, we are using integer I, right? And we are saying I plus 1, right? So instead of that, what if I use a pointer to pass a value, and then we use a pointer value and get a plus 1 into it and again store into it. So what I really mean is, if I say that I am accepting a address here, the pointer variable here, right? So here integer I is no longer accepting a regular value, it is accepting a pointer variable, right? Now if I in the plain, if I write this, then it's a problem. Then what I can write is, I can write like integer temp is equal to star of I. So get the value from the pointer variable. and then let's say temp is equal to temp plus 1, right? And star I is equal to temp. And if I am passing the address, then definitely this value get reflected back into the main method, right? So now instead of passing I will pass the address. Now here you can see that. Okay, Emma, let me verify. First of all, let's put some /n. Output of get data I is equal to, and I am really modifying the value or incrementing the value by 1. The initial value of I is 1, or what we should do is I'll simply say forget about this. I'll say temp is equal to 20,222, right? And then I'm assigning temp to the value of I. Okay, integer temp, of course. Now you can see that the value of I has been modified. So you are passing the address of I. Okay, so this ampersand means that you are not passing the value of I, you are copying the address of I while calling the function. And as you pass the address of I, what happened is inside method, you copied the address in the variable I here in the data method. Then we have initialized a temporary variable called as temp. And then we are assigning the value of temp to the star I. So this star I and this I variable in the main method are referring to the same memory. So if I have to represent the same story in the paint, what I can do is let's create a new canvas. Let's create a new canvas and let's understand what really happened. So in the main method, we have created a variable I. So in the main method, we created a variable I. So of course, I variable have 3 aspects. One is its value, which is 1 initially. Then its label called as I. And also it have an address. Let's assume the address is 000. Now these are the 3 aspects. Now while calling the get data I, what we are saying get underscore data and ampersand of I. So how system will predict it? If I access I, it will give access to the value. But if I access ampersand of I, it will give access to the address. So I am accessing ampersand of I here, right? So how this statement translated by the computer is, it says you are actually calling get data and 000. You are passing the get data and the address of variable I 000. So now let's come to the get data one method or get data method. Now inside get data, what we are doing is we are again creating a temporary variable. So let's create a block. Let's create a block called as a temp. Now first of all, this is the main, and on the right side we have temp method. Oh, sorry, get data method. So here in the get data method, we are creating a fresh block, and again this fresh block have 3 aspects: a temp, it's a label, its value, which we are initializing to 222, and again this temp have its own address. Let's say this is T000. Now what next we are doing is we are saying star I is equal to temp. Now this star I is initialized by the argument of the method or the parameter of the method. Now let's create that argument also. So we have a variable which is called as I. Now this I variable will get what has been passed by the main method. Now in the main method we are passing ampersand of I. So when this I variable have to store it, this I variable will store inside 000. So this is the value of the variable I. Now, but how we are accessing this I variable in the get data method? We are accessing this I variable with the asterisk symbol. So as soon as I access star I, what it means is sorry, if I, as soon as I access star I, what it really means is we are not interested in the address. The star I means I am interested in the value stored at the address. And what we are saying is we are saying star I is equal to 2, 2, 2. So because of this, in the first block, we are actually modifying the memory of the main method. So the new value inside this is no longer 1. The new value inside this becomes 222. And when we come back to the main method and if we print it, the value of this I variable is marked as 222. Any doubts in this? Or if we are clear with this, we will proceed with the next part. I can see something in chat. Anyone have a doubt if the concepts are clear? 10, 15. Okay.
Hello, sir.
Yes, who is this?
Ashish.
हाँ बोल आशीष.
Sir, can you please scroll down the screen
Where?
so that I
In
can see
which?
function declaration
Okay.
in code blocks? Okay. Sir, as we declared the get data 2, we use another variable DARR.
Hmm.
So, but I read somewhere that we cannot change the name of variable when we are accessing data using pointer variable. That is, we cannot write in get data like get data int star j
Where?
when we are in main function we are actually passing I, so we cannot create a variable j in function declaration like we did in the case of get
Here
data
you say
2.
that if I create J, that will be a problem?
Yes, will it be a problem?
No, it will run as smooth as earlier. See, I'm executing the program. Okay, so there will be no problem.
Okay, sir, but we are accessing the location by dereferencing it, but then j might have another location if we have defined it.
How come? Because we are passing the address here, right?
Right.
So that is because of the scope of the variable. See, what is your name? Ashish.
Ashish,
And what is your roll number?
20 T20.
C20, right?
Yes.
So if I say this is Ashish, okay, forgive me if I'm using a wrong spelling. And
No,
you
sir,
are
it is correct.
you're having also C20, right? So for me, let's
Yes.
say C20 is the address. Okay, I should write, not even write here. Let me say uh, C20 here. C20 is the address, okay? And the label is Ashish. And let's say this is the subject you are studying. And I'll say data structures. Okay. Yes, it's the value. So if I have to access it using the roll call, I will dereference it that C20 is the roll number. But what is the meaning of this roll number? I have to say, okay, this C20 means this is the roll call of the student, that is the address. I would refer to the memory to, which will lead to the value. And if I just read DS now, okay. Now, what if I am passing the same information to the exam section? Let's say I'm passing the same information to the exam section. And while passing the same information to exam section, I said that, okay, this is C20. So exam section got it as C20, but exam section have created their own label to access, to refer the C20, and that label might be the PRN. So even if I am using the PRN a new label, my address has not changed, which is C20. Now, if I modify the value of PRN here, let's say DSL, what I'm actually doing is I'm modifying C20 location. So if I come back here, I can modify this DSL also. Okay.
Okay, sir, got it.
Got it. So if this is the concept of actual arguments and formal arguments, or the actual parameters and the formal parameters, right? So argument is the thing that we pass to the function, and like see, whenever we are creating a function, there are two aspects. What is the actual value which has been passed to the function, and what is the value that has been used by the function. So you have to read something called as an actual formal parameters and actual parameters. If you read that, it will be even better. I think that when you are passing the value from here, right? So that is an parameter you are passing to the function, right? Or argument that you are passing to the function. And once I can refer this value as an I, j, k, whatever name I have created in my function. And this get data function is totally living in its own space. This get data function has nothing to do with the main method. So right now I'm calling the get data from the main method. That's why we might think that we must keep the name here, the same name as of main method, but that's not true, because let's say I have another method called as void data, or let's say void disp, a completely different method. And from this method I called get underscore data, get underscore data, and let's say I'm passing ampersand of k. So now I will create this k variable, integer k is equal to 22, and now I'm passing the address of this k variable using the disp method. And now if I call this disp method in the program, if I this method disp in the program, so now what will happen is, as soon as you call disp, your program switches the control from the main method to the disp method. Inside disp method, you are creating a variable called as k with the value 22, and you are passing the address of that k variable. Now from here, the program will jump to the get data method, and it will copy the address of k into the variable j. So it's like C20 and Ashish, right? So let's say here we are calling it as Ashish, and now I am saying I am passing you C20. So exam section got C20, and but they are referring it as a PRN, and they created a new value and they stored that value into the PRN. But what is this PRN? PRN is nothing but the C20 for the void disk. So this value of k will be updated because of the same address. Okay.
Okay, sir, got it.
Right. So I was reading some chat window with some questions. If I Miss Tejas, can you please repeat your question, or maybe you are pointing or giving me some clues to solve it? Tejas, at 10:11, you have posted some message. Miss Tejas, uh, sorry, Mr. Tejas. Tejas, are you there? He's not, I guess he's not in the meeting. Jatin,
Yes, sir.
yeah, ARR2, can you tell me what was your doubt? Or
Yes, on line number 28, you had typed ARR3, so we were telling you that it is ARR2.
yeah, sorry. Right. Okay, thank you.
And sir, I had one doubt. So as you accessed star ARR in printf,
Uh,
so it is printing the first value. So why it is not printing further values? Can you tell me?
I didn't get it. In which printf? Can you tell me the line number? This is the code. Okay, tell me which line.
So line number 34.
Line number 34. This one.
Yes, sir.
Okay, so why it is not printing the further value? See, let me go back to the paint and create a new canvas. Okay, now let's create a diagram again. Array, we have three values. Okay, so let's say we have a zeroth location, we have the first location, and in the zeroth location I have 1, here I have 2, and here I have 3. And this is the first address. Let's say we have 000, right? And then there will be 2 bytes, right? 001, for the first number, and for the second number we will have 002. That will be the first byte for the second number, and the 003 for the second byte, and 004 and 005. So we are assuming that integer is taking 2 bytes to store a number. So this is how the memory has been divided: first block, second block, and the third block. Now when we create a ARR, sorry for my handwriting, that this ARR will be holding a value 0, 0, and 0, right? Now if I say 0, 0, 0, and this ARR, what is the type of the ARR? ARR variable is created against which value? Integer. So what it tells is that if I am creating a variable against integer, then the program must read 2 bytes, 2 bytes at a time to represent a one value, single value. So when I access it as ARR, okay, let me use this. When I access it as ARR, of course, it will print 000. That is a start address. And if I access it as star ARR, it will go to the address. It will go to the address which is 000 and read the first number. Now to read the first number, it has to read 2 bytes. That is 000 and 001, and then it will return 1 as a value, right? So this ARR variable is not representing the entire array at once. No, it's not representing the entire array at once. This ARR is just holding the first value of the array, or the first address of the array. Then if you have to go to the next address or next location, you have to use the formula base address plus index and then size of data. This is what is the formula, right? So look at our printf method. What we are doing in the line number 34, we are saying star ARR. So if I am saying only star ARR, I am completely dropping the right side formula. I am not even considering the index. So obviously the program has no chance to go to the next value, but I have a base address and I'm applying asterisk symbol to the base address. And as soon as I apply asterisk symbol to the base address, it will simply read the first value from the array. So that's why ARR of 0 and the star ARR creates the same value. Is it okay? Or you
Yes, sir, got it. Thank you.
Great. So let me continue with the Atul. What was your doubt? Base address plus index of size. Can you please tell me what is exactly your doubt? Do we have Atul here? Okay, I guess Atul is, I was just telling formula. Okay, fine. Then we have Jatin, sir, why star ARR doesn't print for the value? Okay, Jatin, we just answered it, right? Okay, fine. So this is about pointers. Now it's like we are comfortable with pointers functions, and we are comfortable with some of the conditional blocks in the C. Now let's create a data structure. Before that, let's understand what is a time complexity and what is a space complexity. Or let's understand the time complexity, and then we will create a program and we will try to measure the time complexity of the program. Okay, so let me close this, and in fact, let me create a completely new program for this. Let's say second. Now, let's say for integer, or before even that, let's say I have integer k is equal to 1, integer j is equal to 2, and integer l is equal to, okay, print these values one by one. So I'll be printing %d, comma k, then I'll be printing, I have time, okay, I will be printing %d, comma j, then printf %d, comma l. So we are printing three values one by one. Now, if somebody asks you improve the time required for this program, now what we will assume is there are 6 statements in the program, and we will assume that each step needs a time 1, right? So for every step we need some time, and that time is 1. What is that 1? 1 may be a second, 1 may be a minute, whatever but it's a constant time, that is 1. So if I say I need to execute the first statement, I'll need 1 time constant. If I need to execute the second j statement, again I'll need second constant. And so here I have 1 for this second step. I have one constant, and for the third step also I have 1. So for each of this step I have total time constant 1. So it's not going to change, right? So if somebody asks you, can you optimize the program, how you could optimize the program, because computer has to execute this all steps one by one. Computer has to execute this each and every step one by one. So step number 1, step number 2, step number 3, 4, 5, and 6. All these six steps has to be executed in a particular order from top to bottom. And each step is going to need time quantum of 1. So obviously I have to execute this program, and you cannot reduce the time required by this particular program. So obviously this program have some fixed time requirement for execution, right? And you cannot reduce the time required by the program. So if I have to really, let's say in the numbers, if I have to calculate how much time is required, I can say the program needs 6 steps, 6 time, 60 to execute it. Program needs 60 time to execute, 60 times, right? Now this scenario will change if we add some more things to the program. Let's say what else we can add to the program. If I just simply go here and I'll say for integer I is equal to 0, I is less than some variable n, and I plus plus. Then again there is some task, or let's simply write some code, right? There is some code inside this. Now the things are different. There is a constant time for the statement 1, for the statement 2, and for the statement 3. So there is a constant time for all these 6 statements in the program. But as soon as you hit this for loop, as soon as we come to the for loop, you will find that if I ask you how much time is required by this particular for loop, then there is obviously not a perfect answer. If I have to, like for the above 6 statements, I can guaranteedly say that there are 60 times. This is 60 time required to execute the first 6 statements. What about the for loop? So in the case of for loop, if I ask you what is the time required, can anybody tell me what is the time required for executing this for loop? It depends on which variable? Anyone? N. So yes, that's right. So this n variable is what is we are requiring for executing this for loop. So this n is a decisive factor. N is a decisive factor. whenever we have some constant, like say we do not have this for loop, if the program do not have this for loop, then this program have a constant time requirement for the execution. As soon as we have a constant time requirement for the execution, we say it's a complexity of 1. There are some notations called as big O and all. I will dive into the notations very shortly. Right now we will assume that the constant time is represented by 1. Okay, so whenever you have a program which have some constant time, we will say its time complexity is 1. Let's assume this. There are some other notations called as big O and omega and all. We will dive into those notations shortly. Let's first understand how to try to figure out what is a time complexity of a program. Okay, so whenever you have a constant time and you cannot reduce this, we will assume that the time complexity is 1. You cannot do anything about it. But as soon as there is a variable which is a decisive factor of a program and you cannot figure out what is the exact constant value or time required by the program, in this case, the time complexity of the program is called as n, right? And now n could be 0 or n could be literally infinite. So you cannot predict what is the value of n here. N could be anything. So this n variable, as this n variable is leading to the highest possible time maybe required by the program, if somebody asks me what is the time complexity of this program, then I have two options to say. I can say that, okay, big O of 1, or sorry, let me not use this big O notations right now. Let's say I can say the time complexity is 1 or time complexity is n. So in this case, n is the better parameter to measure the time complexity of a program because it could vary to infinity. So what generally people do is that whenever they have to measure the time complexity of any program, what is the time complexity in general? How much time the program may need for the execution, how much time it could take for the execution. And the time is not in the seconds or millisecond, time is in the terms of CPU cycles. So let's say this 60 is representing the CPU cycle. Okay. So if somebody asks you what is the maximum time this program may take, so let's remove this constant value. So because I don't know what is the constant value of this program because of n, so the time complexity of this program is measured only on the highest complexity that the program have. So what is the highest complexity in this all statement? Right now we have three groups in the program. First group is initializing the values. Second group is printing the values that we have initialized in the first group. And there is a third group, which is for loop. And this for loop is having a time complexity of n, right? This for loop have a time complexity of n. So if somebody asks me what could be the maximum possible time complexity of the program, I will simply say this program have a time complexity of n. This program have a time complexity of n. And even further, let me use the same program. If I go in this program and if I write like this, if integer I is equal to, let's say integer I is equal to 0, I is less than n, I plus plus, and inside this, I again write for integer, let's say j is equal to 0, j is less than again n, and j plus plus. And now there is one more block in the program which is even more time consuming. Now if I deal with this block, if I start talking about this particular block, and if I ask you what is the time complexity, first of all, this first statement n will execute n number of times. The first statement will execute n number of times. And how many times this second statement will execute? This second statement will also execute n number of times. But for each statement, for each inside this loop, how many times this loop will execute? It will execute for the n times, but n into n times, because the outer loop will iterate, and each loop outer for loop iteration will lead to the execution of the inner for loop. So let's say the outer n is 4 and the inner n is 2. Let's assume that the outer n is 4 and the inner n is 2. So how many times this inner for loop will execute? Let's assume. So the outer for is 4. So it enters the loop and then inner loop executed 2 times. So I'll write that, okay, inner loop has executed 2 times. Now outer loop was starting at 4 in that case. Now outer loop reached to the index 3. So again inner loop executed 2 times for the 3 value. Again the outer loop reaches from 3 to 2. So outer loop reaches the index 2 and the inner loop again executed 2 times. Again the outer loop reached the index 1. The inner program executed 2 times. Then we have I should be greater than n. So okay, now the program will terminate. So inner loop has executed 4 times, right? And each time your inner loop is executing, you are executing it 2 times. So let's say 4 into 2, that is 8. And then again 3 into 2, that is 6. Then here is 4 and there is 2. So these many times the inner for loop statements, whatever we write between the opening curly bracket and the closing curly bracket of the inner for loop is going to execute. These many times the inner for loop statements will execute. So obviously, can anybody tell me what is the maximum worst, what is the complexity of this particular 2 for loops? How we can write it? Let's assume this n is 4. This is n value is remaining as 4. Can anybody tell me? What is the worst case time complexity of this? 16. Yes. I should be writing again using worst case. Anyone else? 20. Okay. Anyone else? Anyone else? So think about this and try to write the complexity. Okay, so what is that 32? How you come to the value of 32? Sorry. You added both time complexities for both loops, right? Right. Okay. So you said n plus n. That's what you're trying to say? So you are saying n, that is the 4 times the outer for loop will execute. Yes. Okay. So n plus n you are saying. Okay, that becomes 2n. That becomes 2n, right? So n plus n, I could write it as 2 into n. 2 into n. Okay. Can anyone come up with a better answer? Any other answer? 2n is the time complexity Jatin is saying. So let's play around this. So what let's keep this question floating till tomorrow's session. So I'll give you some other tasks to think, right? So other tasks to think could be while I is less than n. What will happen? What is the time complexity in terms of n for this particular condition? if I say like this, while I is less than n, and inside this, for integer k is equal to 0, k is less than n, and k plus plus. Then how many times this statement statement 1, or let's say statement 2, and here I'll have statement 1. So what is the task here is, every one of you must figure out how many times this statement 1 and statement 2 will execute. And the same thing is for this for loops, statement 1, and here again I'll put statement 2, and same here for this n. Of course, we have discussed this will be n. By the way, this is not n. Uh, this is not 2n. I just got to answer that from the Jatin, that this will be 2n. It's slightly different. You are close to the answer, but it's not 2n. Before that, let me complete this part. So I want you to think about how many times this statement 1 will execute, and similarly, how many times this statement will execute. Here again, I'll write statement 1. So this is what we have to think on, right? So I'm going to create a small program immediately in the poll, and I need you people to attend the poll. Any doubt in this? What is the task? That what you have to think till the next session, and then we will start with the same point again. Yeah, great. So it's fine, great. So let me create a simple poll, a very short program. Attempt the poll. It will tell me how much you have understood about pointers. Let me create a poll. Okay. So the question is available to everyone. You will get exactly 2 minutes to answer. Poll is open. Sorry guys, I was saying that 8 people have got gave a correct result or correct answer. The rest of the classes still haven't given the correct answer. We will focus on this again, no problem. And you are allowed to leave the meeting. If you have any doubt, you can ask me. Else, we will see. I'll see you in the next session tomorrow. No problem. You are allowed to leave the meeting.